Hello everyone. I believe you just finished the day 3 exercise for the number series section. And because number series section is a very important section, but it's also very difficult. So I will take the question 4 as an example to show you how to solve this question. So for any positive integer m, the annotation m factorial denotes the product of the integer from 1 through m. The m factorial is equals to 1 times 2 times 3 times all the number until m. And what is the largest integer n for which 5 to the power of n is a factor of the sum for this term? So in order to solve this problem, we first need to understand it actually asking us to find the prime factorization for this term. And in the prime factorization, it must contain base number 5 to some power and then multiply other numbers. So first, let's find the prime factorization. And before that, we need to simplify this term first. So the first step is simplify it and equals to 98 factorial plus 99 factorial plus 100 factorial. And then we can extract the common factor, which is 98 factorial, and the rest is 1 plus 99 plus 99 times 100. And then further simplify it, it equals to 98 factorial times 10,000. So we can simplify it as this term, and then we should do the prime factorization and count how many 5 does it contains. And because it consists of 2 parts, so we can do it using these 2 parts. And because I think the 10,000 part is relatively easy, and I will do it first and do it second. So let's look at the first one. We should do the prime factorization for the 10,000, and it's pretty easy, right? It equals to 10 to the power of 4, and expand that, it equals to 2 times 5 to the power of 4 equals to 2 to the power of 4 times 5 to the power of 4. So this number, it contains 4 5s. Then let's look at the second term, which is the 98 factorial. We know 98 factorial is equals to 1 times 2 times 3 times 4 times 5 times blah, 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 times until 97 times 98. So there are totally 98 terms in the sequence, and we want to know how many 5 does it contain. So for example, number 5, which is this one, it contains 1 5, right? And can you tell me what is the other numbers that contain 5? Number 10, it contains 1 5, right? Because it equals to 2 times 5, it contains 1. And can you tell me how many 5s does the 25 contains? It contains 2 5s because it equals to 5 times 5. So it equals to 5 to the power of 2, and it contains 2 5. So how can we count that? Terms must contain 5, must be a multiple of 5. So we can divide it by 5 to the power of 1, 5 to the power of 2. But can we divide it by 5 to the power of 3? No, because 5 to the power of 3 is equal to 125, which is greater than 98. So all the terms in this sequence must not be greater than 98. So it must not contain the 5 to the power of 3. So we can only divide it by 5 and by 5 to the power of 2. Let's calculate case by case. When 98 divided by 5, we take the 4 because we want the number of factors that are multiple of 5. And then we can get it equals to 19. So from 1 to 98, there are 19 numbers that are factors that are multiple of 5. And also, we also need to divide it by 25. And to find how many numbers that are multiple of 25. And we can get there are 3 numbers that are multiple of 25. Actually, we can write it down because these numbers are 25, 50, and 75. So this is all the numbers that are factor of 5, and we count how many 5 in each of them. So the sum will be 19 plus 3 plus 4, and is the final answer 26. So there are in total 26 5s in the prime factorization for this problem. So which means in this form, it can be written as 5 to the power of 26 times some other numbers. And this is the final answer for this problem. So hopefully you got the answer correct and fully understand how to solve this problem. And if you want to do more practice in number series and also in other modules, you can enroll in our EMC 8 bootcamp for all the other courses. We have the achievement roll, honor roll, and path to higher awards. And you can also add the WeChat of our EMC 8 assistant for more help. So that's all for today's class. Bye, everyone.